Hi everyone, welcome to PharmaGrid. So today we are going to discuss some calculations related to milliequivalents. Starting with the first question, what is the amount of magnesium chloride having molecular weight 203.3 required to prepare 100 ml of a solution such that 10 ml diluted to 1 liter yields a solution containing 0.30 milliequivalent of magnesium per ml. So read the question carefully. Here we need to find out the amount of magnesium chloride. Okay, we need to find out the weight of magnesium chloride required to prepare 100 ml of the solution. See the clue given in this question, that is 10 ml diluted to 1 liter yields a solution containing 0.30 milliequivalent of magnesium per ml. So here they have given the number of milliequivalents present in 1 ml. Okay, that is 0.30. So let's see, 10 ml of solution diluted to 1000 ml. So here they have given that 1 ml contains 0.3 milliequivalent. Okay, now find out the number of milliequivalents present in 1000 ml. Okay, so it is easy. Take it as x, find out the value of x. X equal to cross multiply. 0.3 into 1000 divided by 1, that is equal to 300 milliequivalent. This is the number of milliequivalents present in 1000 ml of diluted solution, or this is the same number of milliequivalents present in 10 ml of undiluted solution. Okay, see the question here. 10 ml diluted to 1 liter. Okay, so the milliequivalents won't be changed even if you dilute it. Okay, so 300 milliequivalents is present in 10 ml of undiluted solution. Okay, so now take this. You can rewrite it as 300 milliequivalent is present in 10 ml. Now we can find out the number of milliequivalents present in 100 ml, because we need to find out the amount of magnesium chloride required to prepare 100 ml. Okay, so take this value as x or y. So find out the value of x. X equal to cross multiply, that is 300 into 100 divided by 10. That is equal to 3000 milliequivalent. Now we got the number of milliequivalents present in 100 ml of the solution. So but what in the question we need to find out the amount of magnesium chloride. Okay, so we know the equation for milliequivalent is equal to weight in milligram divided by molecular weight into valency. In this equation, milliequivalents we already know, it is 3000 milliequivalent. Weight in milligram we need to find out. Molecular weight, it is already given, that is 203.3. Valency of magnesium is 2. Okay, so substitute all these values in the equation. We will get it as x is equal to 203.3 into 3000 divided by 2. That is equal to 304950 milligram. Convert this into gram. So we will get it the answer as 304.95 gram. So here the correct answer is option B, that is 305 gram. Moving on to the next question. How many milliequivalents of calcium are present in the following solution? Calcium chloride 0.26 gram, molecular weight 147. Calcium gluconate 0.61 gram, molecular weight 448.4. Calcium lactate 0.50 gram, molecular weight 308.3. Sodium chloride 0.30 gram, molecular weight 58.5. Purified water to 100 ml. So in this question we need to find out the total number of milliequivalents of calcium present in this solution. So for that we need to find out the number of milliequivalents of calcium present in calcium chloride, calcium gluconate and calcium lactate, and we need to add them so that we will get the total number of milliequivalents of calcium present in this solution. So first of all, find out the number of milliequivalents of calcium present in calcium chloride. 0.26 gram, molecular weight 147. We know the equation for milliequivalents is equal to weight in milligram divided by molecular weight into valency. Here weight is given in gram, so we need to convert it into milligram. That is 0.26 gram is equal to 260 milligram. Then molecular weight we already know, that is 147. Valency of calcium is 2. So substitute all these values in this equation. We will get the answer as 3.54, which is the number of milliequivalents of calcium present in calcium chloride. Now find out the number of milliequivalents present in calcium gluconate. Weight is 0.16 gram, that is equal to 610 milligram. Molecular weight is 448.4, valency is 2. Again, use the same equation and substitute all these values. We get the number of milliequivalents as 2.72. Again, do the same for calcium lactate, 0.50 gram. Convert this into milligram. We will get it as 500 milligram. That molecular weight is 308.3, valency is 2. Substitute all these values in the equation for milliequivalents. We will get the number of milliequivalents of calcium present in calcium lactate as 3.24. Now we can find out the total milliequivalents of calcium present in the solution by adding all these values of milliequivalents. That is 3.54 plus 2.72 plus 3.24. That is equal to 9.5, which is the total number of milliequivalents of calcium present in the solution. So here the correct answer is option E, that is 9.5. Question number 3. Calculate the volume of sterile potassium acetate injection having strength 2.45 gram per 5 ml to be added to 1 liter of Vamin N to give a total of 25 milliequivalent potassium per liter. Vamin N contains 20 millimole potassium per liter potassium acetate having molecular weight 98.14. So here we need to find out the additional volume of sterile potassium acetate injection to be added to 1 liter of Vamin N. So the final solution contains 25 milliequivalent potassium per liter. Here in the question they have given a data that Vamin N contains 20 millimole potassium per liter. So in case of monovalent compounds, here in the question it is potassium. So potassium is a monovalent compound. So in case of monovalent compounds, millimoles is equal to milliequivalents. That is 20 millimoles can be taken as 20 milliequivalents. That is 20 milliequivalent is already present in Vamin R. Okay, see the data here. Vamin N contains 20 millimoles, that is 20 milliequivalents potassium per liter. Okay, so how much? See the question. We need to find out the extra volume or how much volume additionally we need to add to this Vamin N to give a total of 25 milliequivalent potassium. Already this Vamin N contains 20 milliequivalents. We need to make it as 25 milliequivalents. So how much we need to add it as an extra? That is 5 milliequivalents. Okay, 5 milliequivalents. That is additional 5 milliequivalents needs to be added. We know the equation to find out milliequivalents is equal to weight in milligram divided by molecular weight into valency. Milliequivalents we know it is 5. Weight in milligram we don't know. We need to find that. Then molecular weight is 98.14. Valency of potassium is 1. So substitute all these values in this equation. We will get it as 490.7 milligram. Okay, so here we got the weight, but we need to find out the volume. So how we will calculate the volume? Here again in the question, see there is a clue. The strength of potassium acetate injection is given as 2.45 gram per 5 ml. That is 2.45 gram is present in 5 ml. So convert this gram into milligram. That is 2450 milligram is present in 5 ml. So 490.7 milligram is present in xml. So let xml be the volume. So find out the value of x by cross multiplying. That is 490.7 into 5 divided by 2450. That is equal to 1 ml. So here the correct answer is option C, that is equal to 1 ml. Question number 4. What is the daily sodium intake in milliequivalents of a 69 kilogram patient from the intravenous administration of the antibiotic chloramphenicol sodium succinate having molecular weight 445.2 at a dose of 12 milligram per kilogram every 6 hours? So in this question we need to find out the daily sodium intake in this particular patient in milliequivalents. Okay, so the daily sodium intake will be equal to 12 into 69 into 4. 12 is the dose of the particular drug, that is chloramphenicol sodium succinate, into patient's weight, that is 69 kilogram into 4. How we got it as 4? Because it is the frequency of administration. That is, here it is given that the drug is administered at a dose of 12 milligram per kilogram every 6 hours. Every 6 hours means 4 times a day. Okay, so daily sodium intake is equal to 12 into 69 into 4, that is equal to 3312 milligram. Then the equation to find out milliequivalents is equal to weight in milligram divided by molecular weight into valency, because we need to find out the daily sodium intake in milliequivalents. Okay, so substitute all these values in this equation. We will get it as 7.44 milliequivalents. So here the correct answer is option C. Question number 5. The amount of magnesium chloride having molecular weight 203.3 required to prepare 100 ml of a solution such that 5 ml diluted to 1 liter yields a solution containing 0.15 milliequivalent of magnesium per ml is. So this is the same type of question what we have done before. Here we need to find out the amount of magnesium chloride required to prepare 100 ml of a solution. The clue given in the question is that 5 ml diluted to 1 liter yields a solution containing 0.15 milliequivalent of magnesium per ml. That is 1 ml contains 0.15 milliequivalent. So we need to find out the number of milliequivalents present in 1 liter, that is 1000 ml. Let it be x. Find out the value of x by cross multiplying, that is 0.15 into 1000 divided by 1, that is equal to 150 milliequivalent is present in 1000 ml of diluted solution, or 150 milliequivalent is present in 5 ml of undiluted solution. Okay, so even if we dilute also, the number of milliequivalents will not change. It will be the same in 5 ml also in 1 liter. So we can rewrite it as 150 milliequivalent is present in 5 ml. Now we need to find out the number of milliequivalents present in 100 ml, because here we need to prepare 100 ml of the solution. So let it be x. The number of milliequivalents present in 100 ml, take it as x. Find out the value of x by cross multiplying, that is 150 into 100 divided by 5. That is equal to 3000 milliequivalent. Now we know the equation to find out the number of milliequivalents is equal to weight in milligram divided by molecular weight into valency. Milliequivalents we already know, that is 3000. Weight in milligram we need to find out. Molecular weight is given in the question as 203.3 and the valency of magnesium is 2. Substitute all these values in the equation. We will get it as 304950 milligram. That convert this into gram, that is equal to 304.95 gram, that is equal to 305 gram. So here the correct answer is option A, that is 305 gram. So we have completed today's question discussion series, that is calculation series. If you like this video, please like, share and subscribe. Thank you everyone for watching this video. Have a nice day.